Hello guys, welcome to our video. Group 4 presents Compressive Strength of Cylindrical Concrete Specimens. The concrete cylinder compression test measures the strength of hardened concrete, assessing its capacity to withstand loads before failure. The objective of this test is to determine the compressive strength of a specimen. The significance of this test ensures the quality of concrete by determining its compressive strength, a critical indicator of its ability to support loads and resist deformation. It verifies that the concrete mix design meets the structural requirements of the project, ensuring it can safely support intended loads. It aids in selecting appropriate concrete mixtures for specific applications by assessing their compressive strength, considering factors such as strength, durability, and workability. And its compliance with ASTM C39 is often required by building code specifications and contracts, demonstrating that the concrete used in construction meets industry-recognized criteria and regulatory requirements. For this test, we're going to be needing a compression testing machine, a cylinder mold, and lastly, a weighing balance. First, choose a specific mix design to be used and provide enough cement, sand, and aggregates in accordance with the design. Prepare cylindrical concrete specimens as per ASTM C31. Prepare the mold of size 150 by 300 mm. Mix all the components to produce concrete. Then fill the mold in 3 layers of equal volume, each being rodded for 25 times each layer. For the first layer, rod the layer throughout its depth. Succeeding layers must be rodded in a manner that it penetrates over into the layer below about 25 mm. In the last layer, overfill the mold and then flatten it by using a flat edge and making a sawing motion. Next, label the sample for identification. Leave to cure. Specimen is stored in an environment preventing moisture loss of temperature of 60 to 80 degrees Fahrenheit for 48 hours. It is then placed in a water storage tank. Slowly lift the cylinder out of the water, then let it air dry for a few hours. Prepare the specimen for testing. Place the specimen on the lower bearing block so the axis of the specimen is aligned with the center of thrust of the spherically seated bearing block. Make sure the load indicator is set to 0 prior to starting the test. Apply a compressive load of rate 35 plus or minus 7 psi per second continuously without shock until failure or until the specimen displays a well-defined fracture pattern. Lastly, record the maximum load or stress carried by the specimen during the test and note the type of fracture pattern. In our computation, we use the formula compressive strength is equals to P over A, where we got 12.23 MPa. According to the testing, the specimen can bear up to 216.16 kilonewtons of compressive force. By calculating, the compressive strength of the concrete cylinder tested after 7 days of curing is 12.23 MPa, which falls short of the minimum requirement of 16.25 MPa specified in the project specifications for a M25 or 1:1:2 design mix. This discrepancy suggests potential issues with the mix design, materials utilized, or the curing process. The primary factor believed to contribute to the lower strength is the composition of aggregates used in the concrete. It appears that there was inadequate distribution of fine and coarse aggregates in the mix, resulting in a less compact concrete cylinder despite proper tamping as outlined in the procedure. The failure of the concrete to achieve compressive strength is a serious issue that can have significant structural, durability, and economic implications. Further testing and quality control measures should be implemented to ensure that the future concrete batches meet the required strength specifications. Identifying and rectifying the underlying causes of the failure are crucial steps in ensuring the structural integrity and performance of concrete in construction projects. A thorough investigation is crucial to identify the cause and determine appropriate actions to ensure the concrete meets the necessary standards for safety and performance in the future.